Hi, and welcome to today's lesson. In this first tutorial, we will state the domain, range, and intercepts for various functions. So we're looking at graph reading. We have many terms that we can use to analyze and describe our functions. So let's first look at their definitions. The domain, that's the set of all x values for a given function. In other words, that's every input that has a corresponding output. For the range, that's the set of all y values for a given function, or in other words, every output that comes from an input. The x-intercept, or x-intercepts, if there are multiple of them, are the values where a function crosses or touches the x-axis. Now remember that the x-axis is the horizontal axis when you're graphing. The zeros, well, that's just another name. That's a synonym for x-intercepts. We can call them x-intercepts. We can call them zeros. We could call them roots. We can call them solutions. Really, all four of those words mean the same thing. We're looking at the x-axis for that. The y-intercept, that is where the value of a function crosses or touches the y-axis. Now the y-axis, of course, is the vertical axis. A function will only have at most one y-intercept. End behavior is a specific way of describing the far left side of a graph and the far right side of a graph. We're going to go into more detail in the second tutorial on that. And finally, set notation and interval notation. These are the two notations that we're going to be practicing in this tutorial. Set notation is a method for writing the domain and range using our set marks, these fancy little parenthesis looking things. They're called braces. Interval notation, it's a different method for writing the domain and range. This time we use parentheses or we use brackets. Sometimes we use one of each. When we use parentheses, we're talking about an open circle, meaning that the value is not included. That's what the parenthesis and interval notation means, that we're not including the value. When we use a bracket, that's when we see a closed circle, and that is for values that are included. So we'll talk about that in this tutorial. Let's look at our first example. The directions say to use the definitions that we just learned to analyze each of the graphs below and state the information. It also says to assume that all endpoints and intercepts have integer coordinates. So that just means we're not going to be using any decimals or fractions. If it looks like it crosses at a nice number, we're going to say that that is the nice number. So here's our first function. It's just a closed dot, and then a line, and then another closed dot. Let's talk about domain. Remember, domain goes left to right. These are the x values. So what we need to know is, where does this graph start? We always read, like we read a book, we always read graphs from left to right, so we're going to start at the far left. The graph starts right here with this x coordinate of -4. And then it goes all the way to this x coordinate of +4. So the domain is right here. We just have to be able to describe it. Let's do set notation first. I'm going to show you both notations. Set notation will come first. The first thing we'll write is our fancy little braces. And since we need to tell people that we're talking about domain, we're going to put an X and then a line. This means X such that. And now we will describe what the domain is. In this case, it's every number between -4 and +4. And since these are closed dots, we get to include those values. So I'm going to say from -4 less than or equal to X less than or equal to +4. And that's how I'll write my inequality. I get to use the equal to because they're closed dots. X is in between these two values. Let's also do interval notation so I can show you how that would look. Interval notation. Interval notation is just the interval of the x numbers that we're using, starting with -4, including it, and ending with +4, including it. Since we're including them, we use brackets. Bracket with the -4, bracket with the positive 4, and we just separate the two numbers with a comma. So it doesn't matter to me which one of these notations that you use. I'm going to at first show you both each time, and then eventually I'll let you just pick whichever one you want. As long as you know how to read both of these notations, it doesn't matter to me. As long as you use correct notation, it doesn't matter to me which one you like. Some students are going to think that this is a little bit easier to understand. Once people understand the interval notation, some students are going to think that this is faster because it's less writing. Like I said, it doesn't matter to me, as long as it's correct. Range, now we're looking down up. We're talking about the y values. So forget about looking left and right. Now we're looking down to up. How low does this graph go? Well, this is the lowest value in my range, this value of -1 to -3. And then it goes as high up as this value right here. There's my range, and I need to describe that. Obviously, we're dealing with a different variable, so it's the y's such that. And in this case, we're going from -3 to +1. So it's -3 less than or equal to y less than or equal to 1. If I wanted to do an interval notation, I would just simply put -3, comma 1, and I would use brackets for each point because they're closed dots. X-intercepts, we're talking about where it crosses the x-axis, and that actually only occurs in one location, right here. That's the value of 2. I'm going to write it as the ordered pair 2, 0. And finally, the y-intercept, that's where we cross the y-axis, and it happens once right there, and that's the point -1. So 0, -1 is the ordered pair that I'm going to write. So there's our first example. Let's explore some more. Here's example 2. Now we have a little bit of a curvy function. Starts with a closed dot and it ends with an open dot. Let's see how that's going to affect my domain and my range. Let's talk domain first. We're talking as far left as we can go, which is right here. That looks as far left as we can go, which is -4. And then we travel all the way to as far right as we can go, which is right here, which is +5. So in set notation, I'm going to say all x such that I'm starting at -4, and I get to include it, and then I'm ending at +5, but I don't get to include it. So I'm going to say -4 less than or equal to x, which is strictly less than 5. Notice that I'm not putting the equal to part here because we have this open circle. That's set notation, or I just simply put these two numbers in interval notation, separated by a comma. I'm going to use a bracket with the -4 because we include it because it's a closed dot, and I'm going to put a parenthesis on the 5 because we don't include it because it's an open dot or open circle. So there's our domain. Range, we change our eyes. Now we're going as far down and as far up as we can go. Well, as far down, this is not as low as we go. We actually get a little bit lower down here. So that's the lowest y coordinate that we can use, which is -4. And then we go as high up as right here. Now there's actually two different points that is that same value, but since this one is open, it's not included, this one is more important because that is included. So I'm going to count that as our range from -4 all the way to 2, and we get to include it. Even though this is an open circle, it doesn't matter. This one trumps this other one. It wins, and we get to include it. So I'm changing my variables, so it's all y such that, and we're going from -4 to +2, including both of them. So less than or equal to and less than or equal to. There we go. Notice that our inequalities will always be, increasing from this low number to this high number. So they're always going to be, the alligators are eating in the same direction there. If we wanted to do interval notation, we simply start at -4 and we go to 2 and we include both of those values. X-intercepts, this time we have a few x-intercepts. We have one there, we have one there, we have one there. Remember the directions said assume that they're integers, so I'm going to assume that they're nice values there. -2, 0 is one of them. I'll just read from left to right. 1, 0, and 1, 2, 3, 4, 0. Those are my three x-intercepts, or zeros, or roots, or solutions. And my final, My y-intercept is right here, and that's 0, 2 as an ordered pair. All right. Example 3. I have one last little example in this section to show you one last little thing that can happen. Let's talk about domain. Remember, domain is everything left and right. So I'm going to see as far left as we can go. Well, I see that this arrowhead is right here. This arrowhead tells me two things. It tells me that this graph will always be pointing upward this way, but it also tells me that it will always be pointing left. And since I'm talking about domain, it's important to see that this function starts all the way down there. Now, what number is all the way down there? Well, it's not really a number. Negative infinity is as far left as we can go. So negative infinity is where this domain starts. And then we have every value all the way to, well, geez, we have another arrowhead, which again is pointing all the way up, but more importantly for domain, it's pointing all the way to the right, to positive infinity. So our domain is everything. Every x value. In set notation, we can do our little set marks and put a big fancy capital R, which is a symbol for all real numbers. This means all real numbers. Now, of course, it's set notation, so we need to have our set marks, and we just put a big fancy capital R in there. If we wanted to do interval notation, we will do parentheses, negative infinity, comma, positive infinity, and then parentheses. That also means all real numbers. Now, what I said, infinity, that's not a number. Negative infinity, that's not a number. These are concepts. We're never actually going to reach these numbers, which is why we will always use parentheses with the infinities. We can never use a bracket because we can never actually touch them. So these are two different ways of writing all real numbers for your domain. The set of all reals or the interval between negative infinity and positive infinity. Let's talk about range. Range, we go from down to up. So how far down do we go? Well, this is the lowest that our range goes. It does not go any lower than this. So this is -4. And then the range goes, well, it goes all the way up. In both locations, it doesn't really matter. We go all the way up to positive infinity. So we start at -4 and we go all the way up. So in set notation, all y such that y is greater than or equal to -4. Or in interval notation, we start with the -4 and we go to the infinity. We bracket with the -4 because we're touching it. It's an actual value. We parenthesis with the infinity because we never touch the infinity. Let's do x-intercepts. I see two of them. I see one here at -3, and I see one here at +3. Since those are exact opposites, I might employ my plus or minus symbol, plus or minus 3, comma 0. It's just a fun symbol to show that it's a positive and -3. You could write them as two separate ordered pairs. That's fine. And then the y-intercept is right down here at 0, -4. So now that we've seen three examples of our domains and ranges and our set notations and our interval notations, let's see if we can piece all of this together for our piecewise functions. Okay. So what a piecewise function is when a function has a couple different pieces. I can see this in example 4. We have one piece of the function here and another piece of the function here. So when we're looking for domain and range, and that's all we're going to be looking for in these two examples, when we're looking for domain and range, we have to piece the functions together and get the greatest set possible. So again, let's talk about domain. Left to right. The farthest left we go is right here, and it starts right there. And then we follow this piece all the way to this value, which is right here at the value of 1. And then there's a gap. There are no x values that are being used between these two pieces, between the value of 1 and the value of 2. So we have to skip some numbers, and I'll show you how to do that. And then the next piece of the function starts right here at this x value, and then it goes, well, forever to the right to infinity. So let's describe these two pieces. In set notation, all x such that, let's describe the left piece first. We've got, what is this, 1, 2, 3, -4. So we're starting at -4 and we get to include it. And we're going all the way to +1, but we're not going to include it. So -4 less than or equal to x less than 1. We get to include the -4. We do not include the 1. Since there's another inequality that I'm going to use, I'm just going to separate it with a comma. The next inequality, remember, we're skipping a whole gap of numbers here between 1 and 2. We get the next inequality, which is everything greater than or equal to 2 on forever. So x is greater than or equal to 2 would be good enough. There you go. Let's close the set. And that's our set notation. If we wanted to use interval notation, we just are using these numbers -4 and 1. So I'm going to put a bracket with the -4 and a parenthesis with the 1. Now, if we have a couple different intervals for our interval notation, instead of using a comma, we use that for our set notation, we use this fancy symbol called a union symbol. It looks like a U, and it means union. And it basically just means that we're joining a couple different intervals together. So we've got from -4 to 1, and then we have everything greater than or equal to 2. So I'll start with the bracket on the 2, and then I'll go to infinity. So this union symbol just joins intervals together in interval notation. Let's switch gears, go to range. Let's go down, up, down. Let's go see as far down as we can go, and it looks like that's as low as we go, which is the value of -4. Now we don't actually include it. We're going to travel on up this function until we get to the stopping point here, but there's another piece to look at, and this stopping point gets picked up right here on the other piece and continues to go on up forever to up to infinity. So we start here and we piece it together. This is the same exact value of 0 and continue all the way up. So we start at -4 and we go all the way to infinity. So that's good. We just piece that together. So all y's such that y is greater than -4. I'm not including the -4 because it's an open circle. If I wanted to do interval notation, I would just put a parenthesis on the -4 and I'd go on up to infinity. So you really have to train your eyes as to if you're looking from left to right like domain, or if you're looking from down to up like range, and just kind of piece it together, like I said. Last example in this tutorial. We've got, I guess technically we've got 3 pieces. We've got this line over here, this ray, I guess, and then we've got this other bit of a curve here, and we have a random point right there. Let's do domain, see if we can piece the domain together. Let's start as far left as we can go. Now I know your eyes see this because it's so drastically, you know, such a high slope, I guess. It looks like it's pointing down, but we're not talking about down. We're talking about left and right. This arrowhead implies that we're going all the way to the left. So our domain starts down here at -infinity. It goes from -infinity and then it stops right here at -4. And then we have a big gap where we're not using any x values. And then we pick up our domain again right here at the value of 1. Now it might appear that we're not using the 1 because of this open circle, but because of this random dot here, we do include the 1 because we have an output for this input. So this input is included in the domain. And then we go forevermore. Again, don't look up, look that it's going this way to positive infinity. So let's piece that together. All x such that, let's start down here, -infinity to -4. We don't use this as a number, so I'm not going to use that. I'm simply going to say less than -4. And then I'm going to put a little comma, skip a bunch of stuff, and then pick it back up at 1, which I get to include, and go to infinity. So x, we're talking domain, x greater than or equal to 1. So this is the first piece, which is this right here, and this is the second piece, which is this right here. In interval notation, I would start at -infinity and go to -4, but not include it because it's an open circle. Then I employ my union symbol, and then I'm going to put the 1 with the bracket because I do get to include the value, and go to infinity. So we have set notation, we have interval notation. Learn both, and then you'll get to take your pick as to what you want to do. And lastly, range. Let's see as far down as this graph goes. Well, that's kind of easy to see. It's pointing all the way down to -infinity. So negative infinity is where we're starting. And then we're going all the way up to this open circle, which is obviously not included. And then let's see where we go. Oh, there's another open circle right here. So we're actually skipping this value. This value of 1 is not in the range. After that, we go on forever. We actually have two different outputs here, but who cares? It goes on forever up to positive infinity. So basically, we're doing everything from negative infinity all the way to positive infinity except this value of 1, because there's no output right here. So let's see how we could describe that. Y such that we could say y is less than 1, comma, y is greater than 1, and close the set. That's one way to do it. Or since it's only one value that's being sort of taken out of the range, we could say it's the set of all y's such that y is not equal to 1. That's another way that we could communicate it. Either one of these set notations is fine with me. And interval notation, well, we've got to go from negative infinity to 1 and put a parenthesis to skip that value of 1, and then union that with the 1 to positive infinity. This is everything from negative infinity to positive infinity except the 1. So that's the end of this first tutorial. I encourage you to go back and relook at any one of these examples or any part of any one of these examples if you need further clarification or you just need to see it again. I'll see you in class and we're going to practice this some more. Thanks for watching. Oh, and thank you for the clapping. It's very nice. See ya.